Next bit, where's the meaning of acid? So they don't want weak acid, they want acid. All right, acid is a proton, or you say H plus donor. What is meant by proton? This is hydrogen atom. There is one proton, and there's 0 neutron. All right, so 1 proton and 0 neutron. This is H plus ion. This is also known as a proton because there's 1 proton and there's 0 neutron. Only 1 proton, 0 electron, 0 neutron. 1 proton, 1 electron, 0 neutron. Can you see why it is called a proton now? It's a proton or H plus donor because there's nothing else. You have a plus, you have lost an electron. All right, now what is meant by weak? A weak acid dissociates. You gotta know the English word very well, yeah? Partially into H plus ions in water, whereas strong acid obviously dissociate fully. Okay, how can you use universal indicator to find the pH of a dilute propanoic acid? This is a carboxylic acid. It is meant to be a weak acid, so all carboxylic acid will be weak acid. All right, so how would you use a pH indicator? So pH indicator or the universal indicator, it has a chart, it has a color chart, and it will tell you roughly what pH it is. Yeah, okay, so describe. Yeah. All right, so dip or insert universal indicator, I assume it's a paper, okay, into a solution of dilute propanoic acid. Notice the final color, and then you want to compare, or you want to check against the color chart of the indicator. So they always come in like a box. It's got like a color, it's got a scale. It will tell you roughly the pH. Yeah, it's not like the most accurate thing in the world, but it will roughly tell you the correct pH. Give a large scale use of calcium hydroxide. So this is actually in agriculture. So calcium hydroxide. So calcium hydroxide is calcium 2 plus. Hydroxide is that. You will know the formula where you need 2 of that in order to balance the formula. So there is no charge overall. You need 2 of the hydroxide. So it's added to soil to reduce soil acidity, to reduce its acidity. Because when you think about fertilizers, a lot of the fertilizers, they can make the soil acidic, slightly acidic. So this is alkaline. It's added to soil to reduce acidity. So the use is actually in farming, in agriculture, in farming. Okay, but you got to specify the use. This is where it is used. This is what it is used for. All right, so you need to be aware of what is going on there. Yeah? So you need to specify what's going on. Another use will be you actually use it in the extraction of iron as well. Also, so you can have alternative answer. Also, use in blast furnace to remove acidic impurity. When extracting iron. So you react iron trioxide with carbon, right? And then you get iron and carbon monoxide. But you can get some impurities in the iron trioxide ore, and those are acidic, okay? And they can react with calcium carbonate. Those acidic impurities were actually silicon dioxide, which are actually acidic oxide, okay? Not that you need to know, but anyway. Next bit is again on, next question is on neutralization. You use a pH probe, which you might or might not have seen in school, to measure the pH of the solution until you Okay, you will see how the pH of the solution change. So you see the pH goes from alkaline or basic to acidic. Okay, so this is like titration really. So instead of measuring the endpoint, you just keep on adding HCl to the barium hydroxide. Okay, you add it with a burette. So why does it change from 13.0 to 0.9? What do you have in the beaker? You have this in the beaker. What is this? This is a base. This is an alkali, barium hydroxide. What is a base? It dissolves in water. What is an alkali? It dissolves in water to give you OH minus in solution. So in terms of the ions present in the beaker, originally we have barium hydroxide. The formula is given above here, but you should also know group 2 ion, so Ba2 plus. Hydroxide anion is also a standard, so 2 plus and minus 1. You should know the valence will give you this balance formula, which is alkaline or basic, dissolve in water, or to dissociate in water, dissociate in water to give OH minus ions. Why did I specify that? Because they want me to specify that. Therefore, pH is 13 initially mean at start, yeah. As more HCl is added, the H plus in HCl can neutralize the OH minus present. That is why pH drops to 7.0 at 20.0 cm cube HCl. But as more HCl is added, so neutralization is where the amount of H plus is actually balanced by the amount of OH minus. That's why at pH 7 there is equal amount of H plus, equal amount of H plus and OH minus. They get neutralized, yeah. But then when you add more acid beyond that, there is more H plus. There are more H plus then OH minus. The HCl is in excess, therefore pH becomes very acidic, because HCl is a strong acid, right? Become like 0.9. So that's it. I have gone from being alkaline in the beaker. The beaker has OH minus ions, that's why it's alkaline. I add HCl, so the H plus neutralize the OH minus to give you water. Yeah, H plus OH minus, classic neutralization reaction. And then what happened is beyond the end point, where the H plus equal to OH minus concentration. So that's why you don't get acidic or basic regime at neutral pH, but you keep on adding more HCl, but by then there's more H plus than OH minus, so it becomes acidic. You want it to just neutralize all the thing there. That's where the pH gets to 7, so there's 20.0. You are just static, you are not calculating. So 20.0 cm cube of HCl. Now you need to do calculation. Concentration in mole per dm³ of the dilute HCl. You need to be careful. This is your beaker. This is your barium hydroxide. How much barium hydroxide do you have at first? You have 25.0 cm³ and that much. So you have 25.0 cm³. And what was the concentration again? 0.0500. 0.0500. You add acid. So endpoint So what is meant by the endpoint? The pH 7. By that time, you still have 25.0 cm cube barium hydroxide, which is 0.0500. Capital M refers to mole per dm cube. You must have seen it before. But you also have something else which you have added. Yeah, HCl added. How much have you added? Well, you have added 20.0 cm cube, and the acid that you add is, you don't know the concentration, 20.0 cm cube. So you have added 20.0 cm cube HCl. You don't know the concentration. Let that be Y. I'll just use capital M. So capital M refers to mole per dm cube. That's basically called molar, 0.0500 molar, 0.0500 mole per dm cube. Okay, so now I can do my calculation. But before I do my calculation, I should probably get my equation balanced first. That's very important. Neutralization, right? It's going to give you Ba2 plus Cl minus. So the formula is BaCl2. Do not get your formula wrong as a chemist, yeah? So H2O, you got to balance your equation always. Because of the formula here, Ba2 plus Cl minus, you get BaCl2. So that's why you get 2 Cl. You get 1 Cl there. Add a 2 in front. Now your equation must be balanced because, nope, it's not. You need 2 H2O. 2 oxygen there, 2 hydrogen. Extra 2 hydrogen, 4 hydrogen. Okay, so there's quite a lot of space to do your working here, and it's 3 marks, so try not to lose anything. So what have we got here? We want the concentration of the dilute HCl. So actually we don't care about this at all. I think the most important thing is this balance equation. All right, so how much has reacted? So the mole of HCl, so I like to do my calculation using fractions like this, but your school teacher might have taught you using another method, which doesn't matter as long as you get to the correct answer. What have I done? I have mole ratio divided by the mole ratio of the other thing. I done this wrong way around. It's 2, 1. Okay, I could have done barium hydroxide mole divided by HCl mole, then I'll just get 1 over 2. All I've done is balance equation, get the mole ratio, follow the equation itself. So it's HCl is 2 on top, there's 1 is 1. If I've got this the other way around, I just have 1 over 2. It doesn't matter, it will still give me the correct answer because I'm doing the correct mathematics. Okay, so the mole of HCl is equal to 2 times the mole of barium hydroxide. I'm dealing with aqueous solution of HCl, so I need the concentration of HCl in mole per dm cube. My volume used was 20.0 times 10 to the minus 3 dm cube. In dm cube, in mole per dm cube. So I'm left with mole here. The 2 is, the 2 is the mole ratio, so I keep 2, and then now what is my mole? My mole of barium hydroxide is 25.0 times 10 to the minus 3. That is the volume in dm cube, multiplied by the concentration in mole per dm cube. I guess the key thing here really is just the mole ratio that you need to get right, yeah? And this should be an easy 3-mark question. All of this divided by this, and you will get 0.125 mole per dm cube. I guess in O level they use the word mole per dm cube, which is the same. If you do math, you will know what I'm talking about. Okay, moving on to the next question. Next question, sulfuric acid. So this is a typical neutralization reaction. So what actually happened is you use a pH probe here. Okay, what did you start with? You have a pH of solution in a beaker, and you originally have H2SO4 in a beaker. At this point, your beaker is just 25.0 cm cube of 0.05. mole per dm cube H2SO4. At this point, pH 7. Okay, so that is the point where you actually have H2SO4 and NaOH, but the H plus amount, so the mole of H plus equal to the mole of OH minus, neutral. I'm not talking about the mole of H2SO4 and mole of NaOH, I'm talking about the mole of H plus and OH minus. This is your ionic equation, obviously. When the mole of H plus equal to the mole of OH minus, you're going to get water, pH 7. Here you have, remember, beyond that point, you're going to have more hydroxide than H plus, because you keep on adding hydroxide. So more mole of OH minus than the mole of H plus. Therefore, it becomes alkaline. So this is alkaline or basic. Here you have acidic. So basically, if you think about the ions present, why it goes from 1 to 13.0. Initially, so I'm putting things into word now. Initially, the beaker only contains H2SO4, only H plus in solution. Therefore, acidic, strongly acidic, pH 1.0. Then they talk about the changes. They do not talk about start and end. You also need to talk about the middle bit, which is the changes. Okay, as NaOH is added, the OH minus introduced, so or the OH minus added neutralizes the H plus to form water until pH 7. Therefore pH increases until 7, where the mole of H plus equal to the mole of OH minus, so you get neutral pH. Beyond that, so after that pH 7, more NaOH is added. You see, you are just keep on adding NaOH, so more NaOH is added. Therefore, the mole of OH minus is greater than the mole of H plus. It becomes more alkaline, or more basic, and therefore eventually you get pH 13, which is strong base, so strong alkali, because that's the pH of strong alkali like NaOH. Yeah. Use the graph, state the volume that just neutralizes. I think I show you pH 7 there just now. pH 7, so there's a straight vertical line, so it's 20 cm cube. 20 cm cube. Now you need to do the calculation.